Hello everyone, today I have this problem on algebra which I found from a test paper. Consider the equation in x, 8x raised to 4 minus 16x cubed plus 16x square minus 8x plus a is equal to 0. The sum of all non-real roots of equation can be 1, 2, half or none of these. A belongs to real numbers. This is a multi-correct question, so pause the video here and try it on your own and I'll come up with a solution. Before coming to the solution, here are some important concepts that will be required in this problem. If a polynomial has a non-real which is complex root, then the conjugate of that complex number will also be a root of the polynomial. Here's the proof for it. I think this is a common result that most of you will know, but still here's the proof. I'm taking second degree equation just for convenience. If az square plus bz plus c is equal to 0, where a, b, c are real numbers and z is a complex number, if we take conjugate of this, as you know, conjugate of a real number is the real number itself, so it will remain the same. And for z we let z bars, and yeah, so the only difference is that z is replaced by z bar. So you can, if z is a root of the equation ax square plus bx plus c equal to 0, and as you can see, z bar is also an equation. It's also a root. So in other words, non-real roots always exist as conjugate pairs. The polynomial always has an even number of non-real roots like 0, 2, 4, etc. In our case, it's a 4 degree equation, so it can either have 0, 2 or 4 non-real roots. Now we'll go on to analyzing our given equation. Now first of all, we'll see that sum of all the roots, both real and non-real together, will be equal to minus b by a, as you know, is equal to 2. Now let's analyze the equation f of x. First of all, we'll take f dash x. We get this, and if we take 8 common, we get 4x cubed minus 6x square plus 4x minus 1. So I think you will know that x minus 1 raised to 4 is x raised to 4 minus 4x cubed plus 6x square minus 4x plus 1. Actually, I would suggest you to remember this pattern of 14641 because it will be helpful in finding patterns in such equations. This is basically just 4c0, 4c1, 4c2, 4c3, 4c4. Similarly, you can remember for a raised to 5 also, which will be 1, 5, 10, 10, 5, 1, which is 5c1, 5c0, 5c1, 5c2 till 5c5. In which here, based on this, we can write this expression as x raised to 4 minus x minus 1 raised to 4. Now we'll use this property a square minus b square is equal to a minus b into a plus b. But if we write it as x square is x square whole square minus x minus 1 square whole square. So we can split it using that property into these two equations. This one, it can't be split anymore, so we'll just write it as 2x square minus 2x plus 1. This one again we can split it using the same property. So this will be equal to 1 and this will be equal to 2x minus 1. So finally f dash x is equal to 8 into 2x minus 1 into 2x square minus 2x plus 1. If you see the sign of f dash x, for x greater than half it will be positive, for x less than half it will be negative, so we can say it will have a local minima at half. So now we know that x equal to half is the only point of extrema and it is a local minimum. So now and also I found f of half is equal to a minus 3 by 2 in case it is required. So we have three cases depending on the nature of f of half. Case 1, if f of half is equal to 0, we can say x is equal to half is a repeated root of f of x. Why is it a repeated root? Because like I said, this equation can have 0, 2 or 4 non-real roots. So correspondingly it can have 0, 2 or 4 real roots. And in this case we can see x is equal to half is the only root, but since it needs to have at least 2 roots, so it has to be a repeated root, and there will be 2 other non-real roots. Here sum of real roots is equal to half plus half, which is equal to 1, and as we found before, sum of all roots is equal to 2. So we can easily say that sum of non-real roots should be equal to 2 minus 1, which is 1, which is option A. Now case 2, if f of half is greater than 0, so we can clearly see it has no real roots, so all non-real roots. So sum of non-real roots is the same as sum of all roots is 2, so which is our B option. Now case 3 is a bit complicated. When f of half is less than 0, it will have two unequal roots, unequal real roots and two non-real roots. Now one thing we can see from observation that these roots will be symmetric about x is equal to half. Why? Because f of x is symmetric about x is equal to half. Now I'll show you the proof for that. So f dash x, like we found out, is 8 into x raised to 4 minus x minus 1 raised to 4. So integrating this, we get f of x in this form. Now we could find c using maybe writing f of 0 value, but we don't need c. I just need to prove it is symmetric about x equal to half, so I need to prove f of half minus h is equal to f of half plus h. So first we find f of half minus h, which is equal to this. Now if we take this minus outside, we'll get this expression. Now f of half plus h will be equal to this, and now again if we take this minus outside, we'll get this value. And I think you can clearly see that these two expressions are equal. Basically f of half minus h is equal to f of half plus h. So f of x is symmetric about x is equal to half. Now you can use this result to say that these two roots will also be symmetric about x is equal to half. So these roots will be of the form half plus k and half minus k. So their sum will still be equal to 1. So again, sum of non-real roots will be equal to 2 minus 1, which is equal to 1, which you already got. So the only two possibilities are 1 or 2, which is a or b. So our final answer is AB. This is a really challenging question, but I hope you are able to solve it and get the same answer. If you have any doubts or any suggestions, you can comment down below. Thank you for watching.